Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 17, 2025, just yesterday. This paper reveals a critical gap in LLM abilities. While they're great at understanding complex context, they still struggle to generate equally sophisticated, long-form outputs. The paper is titled A Survey of Context Engineering for Large Language Models, and it provides a new framework for tackling this exact problem. It introduces context engineering, which is the systematic optimization of information given to models to build more advanced, context-aware AI. Also, the authors shared a repository on GitHub to go along with the paper. It's a fantastic resource, essentially a massive curated list with hundreds of papers, frameworks, and guides on context engineering. It's a real goldmine if you want to explore everything from prompting to production-grade AI systems. Building on that roadmap, this next figure provides a detailed taxonomy of context engineering. It's organized into sections like foundational components, implementations, and evaluation. For example, under components, we find techniques like chain of thought, which prompts a model to reason step by step, drastically improving its problem solving. Another is retrieval-augmented generation, which lets a model pull in external, up-to-date information. These pieces, from basic prompts to complex multi-agent systems, form the toolkit for improving how models use information and close that gap between understanding and generation. So, to visualize how these components come together in practice, this next figure presents a timeline of context engineering's evolution. It's laid out like a growing tree from 2020 to today. The main branches represent key implementations, like advanced retrieval-augmented generation, memory systems, and tool-augmented reasoning, which is about letting models use external software tools to help them think. You can really see the progression, from foundational techniques at the bottom to the sophisticated multi-agent systems we're seeing now, like AutoGen and Crew AI, at the top. Okay, so to really crystallize the difference between the old and new methods, this table provides a direct comparison of prompt engineering and context engineering. You can see that prompt engineering is described as static, basically a fixed instruction. It's also stateless, meaning it doesn't really have a memory of past interactions. In contrast, context engineering is dynamic. It assembles information from multiple sources. It's inherently stateful, allowing it to manage memory and state. This modular approach is far more scalable and avoids the brittleness that comes with trying to manage long, complex prompts. So, building on that comparison, this next diagram really lays out the entire context engineering framework. On the left, you see the various inputs, things like long-term memory, available tools, the user's prompt, and retrieved information. These are then fed into what are called the foundational components on the right. These are split into three layers: context retrieval and generation, context processing, which includes self-refinement, where a model essentially improves its own work, and finally, context management. This structure really visualizes how these pieces integrate to build more sophisticated, context-aware systems. Alright, so let's dive deeper into one of those key system implementations, retrieval-augmented generation. This diagram shows how it works. On the left, the system takes in external information from sources like documents or databases. It then processes this using one of three main architectures: modular, agentic, which involves using smart AI agents to actively search and process information, or graph-enhanced. The whole point is to feed better, more relevant context into the LLM for specific applications, like knowledge retrieval or memory optimization, which you can see on the right. So these sophisticated systems like retrieval-augmented generation are all part of this larger framework the authors call context engineering. Ultimately, this paper argues that to truly advance AI, we need to systematically design these rich information payloads for our models. And a really critical finding they highlight is a strange imbalance. While models are getting incredibly good at understanding complex contexts, they still struggle to generate equally sophisticated, long-form answers. Closing that gap is the next big challenge. That's all for today. Thanks for tuning in.